Hello everyone. Today's problem was submitted by a viewer and it says the point O is at the top of the vertical tower of a height h, which stands in the middle of a large horizontal plane. A projectile P is fired from O at a fixed speed u and at an angle alpha above the horizontal. Show that the distance x from the base of the tower when P hits the plane satisfies gx squared over u squared equals, okay, so some large expression. And then it says, show that the greatest value of x as alpha varies occurs when x is equal to h times tan of 2 alpha, and find the corresponding value of cosine 2 alpha in terms of g, h, and u. Show further that the greatest achievable distance between O and the landing point is u squared over g plus h. Okay, so essentially a physics problem. And the key to this one is going to be splitting the velocity of this projectile into a vertical and horizontal component. Once we have the vertical component, we should be able to compute very easily the amount of time it takes for the projectile to hit the ground. If it's fired at some angle, we take the vertical component and we basically imagine it's been fired directly vertical at that speed, the vertical component of the whole velocity. We can easily compute how long it takes to hit the ground. And once we have the time that it takes to hit the ground, what we can then do is take the horizontal component of velocity. We can find out how far the projectile goes horizontally, and then we have exactly the point at which it lands. Okay, so let's start by drawing a diagram here. We have a vertical tower of height h. Okay, so we're in the middle of a plane. This is the point O. And we have a horizontal coordinate as well. So the projectile is fired from the point O at a fixed speed u and an angle of alpha. So this is the setup we have there. And the projectile is obviously going to go something like that. If we split this up into a horizontal and vertical component, like I said, then we can take this vertical component and imagine the projectile is being fired up, directly up at that speed. And then we can compute the amount of time it takes to go up and back down. That will give us some value of t. And then to figure out how far horizontally it goes, we take this horizontal component and we imagine it moves at that speed for a time interval of length t. Okay, so I will say Vy is equal to u times sine alpha, and Vx is equal to u cosine alpha. Okay, so this is the vertical and horizontal component of the horizontal and vertical component of the initial velocity. And then what I want, oh man, I mean, I know there's a whole bunch of basic, essentially high school level formulas for the amount of time it takes to travel a distance. What I'm going to do is I'm simply going to say that the distance something travels is equal to the integral from 0 to t of the velocity as a function of t dt. And the velocity is a function of t in the y direction. I guess I should call this, let's call these both the velocity at time 0. The velocity at time t is equal to the velocity at time 0 plus, well, I suppose if we are using a sign convention that up is positive, it'll be minus g times t, right? The acceleration is constant in g and it's downwards. So g is the positive gravitational constant. So the distance that it travels is equal to the integral from 0 to capital T of Vy at time 0 minus g times t dt. So the distance is Vy of 0 times t minus g capital T squared over 2. And so this is for any amount of time that it travels. And what I want is I want to set the new position. If we call this 0, then the new position at when it lands is negative h. So if I set this equal to negative h, I'll rearrange as well. I have g t squared over 2 minus Vy of 0 capital T minus h is equal to 0. Let's write this as g t squared minus 2. What was Vy of 0? It was u sine alpha minus 2h is equal to 0. So I need to solve for t now. T is equal to 2u sine alpha plus the square root of 4u squared sine squared alpha plus 8gh divided by 2g. That should work. And we probably have some simplification. So capital T is u sine alpha over g plus u squared sine squared alpha plus 2gh in a square root, again divided by g. Okay, so this is the amount of time that the projectile spends traveling. Okay, and the distance so then the distance that it travels in the horizontal direction, where the horizontal velocity does not change. So the distance in the horizontal direction is called x according to the question. X is just equal to t times Vx0. So x is equal to t times u cosine alpha, I think. Yep. Okay. So x is equal to this quantity, this capital T times u cosine alpha. So I have u squared sine alpha cosine alpha over g plus, so we'll probably have to do some simplification of some sort. Times u cosine alpha. How are we going to do? What kind of simplification can we do? So there's some double angle formulas given in the answer, and in fact, it's also written in terms of x squared, not in terms of simply x. Okay, so maybe something we can do instead. Yeah, I've essentially solved for x, but the expression that's given that we actually have to show, I'm going to write it out here. Gx squared over u squared is equal to h1 plus cosine 2 alpha plus x sine 2 alpha. So they actually haven't, in the expression here, they haven't solved for x because there's an x squared there and there's also an x there. So what I'm going to do is I'm going to take this expression that I have, which the time satisfies, and if I multiply that by if I multiply this by u squared, multiply both sides of this by u squared times, like if I multiply both sides by that squared, then I might be able to group things in a particular way. Okay, so let's take that equation. G times t squared let me just copy it like this. Okay, so I know that the amount of I know that the variables have to satisfy this, where capital T is the amount of time it spends in the air. I'm going to multiply this whole thing by u squared cosine squared alpha. This is the horizontal distance. In fact, why don't I instead write it like Vx squared. So I have G times Vx capital T all squared minus 2u sine alpha T Vx squared minus 2h Vx squared is equal to 0. So the horizontal velocity times time is equal to the horizontal position, which is simply x squared here, minus 2. And this one, I'm going to keep one of these as Vx, and the other power I'm going to write as u times cosine alpha. So I have a u squared sine alpha cosine alpha times x minus 2h u squared cosine alpha squared is equal to 0. Okay, so now gx squared minus 2 sine alpha cos alpha, that's equal to sine of 2 alpha. And here I have minus 2h u squared. Cosine alpha is I mean, I'm cheating here because I'm looking at the expression we're trying to derive, and I know that I mean, I would have to derive, I don't have the trig identity memorized, but it's very familiar looking. If I take this and divide by 2, that's equal to cosine squared alpha. So cosine squared alpha times, I'm just going to write it like this, 1 plus cosine 2 alpha divided by 2. That is cosine squared. So we have a factor of 2 that gets canceled. And if I divide by u squared as well, I have gx squared over u squared. I'll put these other terms on the other side is equal to h times 1 plus cosine 2 alpha plus x sine of 2 alpha, which is the expression we wanted to derive. I mean, again, I have cheated because I don't remember the trig identity for cosine squared, but I know it looks something like this. You know, I could look it up or derive it or something like that. But yeah, so what was the key here? The key was writing down an expression here, essentially, that the distance that the particle travels in the vertical direction is related to, I mean, it's essentially this expression. And then what I did was I solved for t such that it hits the ground after that amount of time. But we don't actually need that. We're going to take this expression that t has to satisfy and just manipulate that to get the expression that we want. Okay, so now the next part of the question, show that the greatest value of x as alpha varies occurs when x is equal to h times tan of 2 alpha, and find the corresponding value of cosine 2 alpha in terms of g, h, and u. Okay, so I mean, if I look at this and think of this as a let me think. So what I'm going to do is I'm going to assume that all the variables are fixed, in particular g, u, and h. I'm going to think of alpha as being a variable we control, and x as being a function of alpha through this relation. So I'm thinking of x as being a function of alpha. And what I want to do is I want to take a derivative. I want to take a derivative of f with respect to alpha. And we're going to use this relation to do that using implicit differentiation. So let me rewrite this expression first as g f alpha squared divided by u squared is equal to h plus, h times 1 plus cosine 2 alpha plus f of alpha sine 2 alpha. And all I'm going to do is take a derivative with respect to alpha. So on the left, I get 2g f of alpha f prime of alpha divided by u squared. On the right, I have 2h sine of 2 alpha, I guess that comes with a negative sign, plus f prime of alpha sine 2 alpha plus 2 f of alpha times cosine of 2 alpha. Okay, now when this function f of alpha reaches a maximum, f prime of alpha is equal to 0. So this substituting f prime is equal to 0, we get 0 is equal to negative 2h sine of 2 alpha plus 2 f of alpha cosine 2 alpha. And we see now pretty much exactly what we want. If I rearrange this, I have f of alpha is equal to 2 cancels. I have h tan 2 alpha. That is what we want, right? Yeah. In fact, maybe I call this alpha star is the maximizer. So whatever the maximizing angle is has to satisfy this. And that's what we were asked for, showing that the greatest value of x occurs when x satisfies this. Find the corresponding value of cosine 2 alpha in terms of g, h, and u. Okay. So cosine 2 alpha star. So I'm thinking I might go back up to this equation and substitute what f of alpha star is and see what happens. I'm not sure if that will give me what I want. Okay, well, let's copy this. And everywhere I see f of alpha, I'm going to replace it with h tan of 2 alpha. Okay, and f of alpha here. H times tan of 2 alpha. Will this get me what I want? I'll write this as, let me multiply and divide by cosine alpha. Does that help? Maybe. I mean, I can just group that cosine alpha with that cosine alpha. It looks like it's going to be a very messy expression, but it should lead to what we want. And cancel an h everywhere. So GH tan squared 2 alpha divided by u squared minus 1 is equal to cosine 2 alpha times tan squared alpha plus 1. Yeah, this looks really messy. Maybe I've made a mistake, or maybe there's a simpler way of expressing this, but I simply get that cosine of 2 alpha is equal to GH tan squared of 2 alpha divided by u squared minus 1 times 1 plus tan squared alpha inverse. This is in fact 1 plus tan squared is what? Secant squared? Sorry, this should be 2 alpha. Not that it really makes much difference. That's alpha sine cos s squared plus c squared equals 1 divided by cosine tan squared plus 1 is equal to secant squared. So this is secant squared 2 alpha to the negative 1. And so that's just cosine squared 2 alpha. Interesting. Okay. So then I have, if I take reciprocals and so on, I now have cosine of 2 alpha is equal to this quantity to the power of negative 1. Oh wait, hold on. It doesn't want us to write this in terms of alpha. Yeah, okay, hold on. I want to go back. We have to write this in terms of only g, h, and u. So there must be some other simplification we can do here. Let me start with the expression again. G over u squared times h squared tan squared of 2 alpha is equal to h 1 plus cosine 2 alpha plus h tan 2 alpha sine 2 alpha. Cancel an h everywhere. Let's expand all the tangents. GH sine squared 2 alpha over u squared cosine squared 2 alpha is equal to 1 plus cosine 2 alpha plus sine squared 2 alpha over cosine 2 alpha. Okay, let's multiply through by cosine. Okay, so this becomes 1. And I suppose I can multiply through by cosine again. I'll also replace this with 1 minus cosine squared 2 alpha. Now we could treat this as a quadratic expression. So I have GH times 1 minus c squared over u squared is equal to c squared plus c. So GH minus GHC squared is equal to U squared C squared plus U squared C. Let's put everything on one side. We have U squared C squared plus U squared C plus GHC squared minus GH is equal to 0. And so U squared plus GH C squared plus U squared C minus GH is equal to 0. So I have C is equal to do I have a sign error somewhere? So I mean, there's cosine of 2 alpha in terms of all these variables. What does the negative part of this represent? I mean, this is what was asked for. It's just, it does not look like a nice expression at all. Unless I made a mistake somewhere and things should simplify. I'm going to leave it at that. I mean, it's essentially just algebra figuring this out, and you have to get lucky and understand the easiest, most direct way to there. Okay, the last part of the question, show that the greatest achievable distance between O and the landing point is U squared over G plus H. Okay, I'm going to rewrite the expression that relates the distance to the angle. And the total distance squared is equal to x squared plus h squared. That's the total distance from the landing point to the original point of the projectile, right? There's O, there's where we land. Okay, so that's x and that's h. Okay. So what do I want to do here? Well, I again want to think of this as a function of alpha. D squared of alpha is a function of x squared of alpha plus h squared. What's the easiest way? Easiest way to do this? I mean, I can take a derivative of this and set it equal to 0, and then try and solve for d. Is that the easiest thing? I suppose, hold on, d squared of alpha, let's multiply it by g over u squared. This is equal to g x squared of alpha over u squared plus h squared. And so I have g times d squared of alpha divided by u squared is equal to this. Oh, but I have an x in here. I don't want an x in there. I want everything in terms of d, because this x has to be treated as x of alpha. Well, hold on. The greatest value of d is going to correspond to the greatest value of x. Of course. Maximizing d is the same as maximizing x. So then we have d squared. The maximum value of x satisfies, ooh, where is it? This. Right? This is the maximum horizontal distance we can get. It's h times tan of 2 alpha squared. Okay, plus h squared. So I have the maximum distance is equal to h squared secant squared 2 alpha. So d squared, so d is equal to h divided by cosine 2 alpha. So am I really supposed to take this expression? I must have a mistake here because things are not simplifying nicely. What have I done wrong? Okay, I'm going to try and figure out, I think maybe I just didn't simplify this expression for cosine 2 alpha in the right way. So I'm getting a different expression here now. I wonder if I made some simple algebra mistakes earlier on. Okay, multiply through by c squared. So that doesn't seem to work. Did I mix something up earlier here? Multiply through by cosine. So 1 just disappears there. This cosine pairs with the 1. The cosine squared becomes 1. Okay, multiply by cosine again. Why does this not work down here? Why am I getting cubes? Okay, well this, hold on, becomes gh squared s squared simply u squared h c squared plus u squared h c c squared plus s squared, and that's equal to 1. Okay. I'm getting the same thing. Again, this looks very messy. Can this be simplified somehow? I mean, maybe that's as much as we can do, and we just have to simplify this. D is equal to h over c. So it'll be h times 2 gh plus u squared divided by, wait, yeah, okay, negative u squared plus square root of u to the 4 plus 4 gh plus u squared. Like, okay, let's multiply by u to the 4 plus 4gh plus u squared plus u squared. Okay. I don't see how this is going to simplify anything. Such a mess. Okay, gh plus u squared cancels, and h cancels. That cancels. We're left with 2g in the denominator. So I have d is equal to u to the 4 plus 4 gh 4g squared h squared plus 4 gh u squared. Oh, that is equal to something squared, isn't it? Of course. Oh my goodness. Oh, this quadratic must factor very nicely. Okay. I'm doing a lot of unnecessary work because I didn't recognize something. So C, where's the original quadratic? Um, so I have u 4 plus 4 g squared h squared plus 4 ghu squared under square root. And that's equal to u squared plus 2gh all squared under square root. Okay, I would have to do some thinking of exactly why we take the positive over the negative, but that's what I'm going to do. So I have 2gh, well, gh divided by u squared plus gh. That is cosine of 2 alpha for the maximal horizontal distance. I should have realized that. This quadratic, we must be able to factor that very easily. But anyway, so then the distance, the total distance from O, not just the horizontal distance, but the full distance, we said is h divided by cosine of 2 alpha. So this is equal to h times u squared plus gh divided by gh. So d is equal to u squared plus gh divided by g, or u squared over g plus h, which is the expression that was originally given. Okay, so that last part took a lot longer than it should have, simply because I didn't actually try and expand this thing under the square root. As soon as I expanded it, I recognized that it could be factored. Yeah, so I mean, I guess everything I did here is correct. It's just I didn't simplify it, and I ended up with a big mess. I mean, this is a really nice problem, but it's really only the very, very, very first step that I think is the only important part that gives you any insight into how to solve everything. So splitting up the initial velocity vector into a horizontal and vertical component. Using the vertical component, that tells you how much time the projectile spends in the air. And then, of course, that time that it spends in the air is the same for how much time it spends traveling horizontally. The rest of the problem was really nothing more than algebra and manipulating stuff on the page. I mean, I'm happy I got there in the end. Yeah, but I think it's the first part that's really the most important. So thanks for the submission, and thanks for watching.